This video we are going to understand the count complete subarray in an array, and this is the Leetcode problem 2799 and we are going to do with the Java solutions, right? So let's start. Hey everyone, welcome back to the channel. In this video we are going to solve this problem of today Leetcode contest question. So this is the daily Leetcode contest series in which we are going to cover the questions and answer. So this is a great problem for practicing subarray and the logic and working with the hash sets in the Java, right? So this is simple solutions that we are going to do today, right? And let's understand here. So you are given an positive integers, right? And a subarray is called complete if the number of distinct elements in that subarray is equal to the number of distinct elements in the entire subarray. Okay, and finally we have to return the number of complete subarrays for this array, right? For example, let's understand this example one, right? We have given 1 3 1 1 2 and the number of distinct elements in the whole array is 3 1 2 and 3. So we want to count how many subarray also contain exactly those three distinct numbers. So the complete subarrays are like these are the subarrays having the 1 2 3 as a elements in the subarrays, right? And that is why the output is coming 4 here. Okay, so the there is a approach that we are going to understand first. Like, let's suppose the simplest way to solve this is with the brute force approach, right? So we will generate all the possible subarrays using two nested loops, and for each subarray we will count how many distinct elements it has using a hash set. If the size of the set equals to the total distinct count in the original array, then it's a complete subarray, right? So let me go through the code, then you will understand, right? Okay. Okay, so as you can see here, right, first of all, what we have done, so we have created a set to find the total number of distinct element in the entire array. So for that, what we will do, we'll create a set. You can use like set integer full set, and then this is a new hash set, right? And like that we will create a set, and for we will iterate all the elements of the array, and we'll keep adding the each element in the set. Full set dot add, and we'll do add set, then we'll get all the here. Why we are going to do, because I want to see the unique element, distinct element in the entire array will have on this full set. Okay, so we can compare later. Today next what we will go, total distinct element we will find how full set dot size will do, then we'll understand the what we have in the elements in the array which is distinct, right? So 1 2 and 3 was the distinct element that we can see, so total size will come as a 3 here. So the initial count will take as a 0, and the n will take as a length, right? That will keep here like that only. For will for the calculating the subarrays, what we will do, we will iterate all possible starting indices of the subarray, like start from the 0 to the n, and then we'll create a subarray, right? Subset will create, right, for the subarray, and this is similar to the previous one that we have created, right? Here we will create a full set, here we will get a subset, right? Then what we will do, we'll start from the end, and we'll start from the start, and we'll keep going to the last, right? We'll keep adding all the element into subset, right? So all the elements of the nums will also get added here, but here the subarrays we are calculating, we are adding the subarrays, right? Because start is starting from the 0, and end will start always from the start, and will keep moving ahead. So you will get all the possible subarrays, right? And this is, we are going to give the name as a subset. So subset have the elements of each subarray, right? Let's suppose the initial subset we have 1 3 1 2, so that will get added here, right? Next we are going to check for other, like that each time in the inner loop will have, right? Means first at start 0 we'll have the subset 1, at start 1 we have subset another one, like that we will calculate, right? And then we'll check the size, subset dot size is equal to subtotal distinct, then we'll do count plus plus. Okay, and then once this sizes are equal, it means all has the distinct elements, right? So let's return the final count of the complete subarrays, right? like this we will do. And so this approach is will be accepted, and you can try for the what we can say, try for the better approach, right? So in this why I'm saying you can try for the better approach, because see, this is super simple and clean, right? But we are looping over all the possible subarrays using a hash set to keep track of the distinct values, and then we are just compare it to the distinct count from the full array. But the solution runs in O of NQ. As you can see, we have three arrays, three loops for at line 17, line 22, and that's why it becomes what? O of n square time, not n square, sorry, n square. Okay, so two loops are there, for loop 17 and 22. So we have O of n square, not O of nq, sorry. So the total time complexity will become O of n square time due to the nested loop. Two nested loop will create, and the subarrays will create a O of n square time complexity, right? O of n square, right? Of n square will be the time complexity. Okay, so it's not the most optimal, but it works perfectly within the problem contains constants, because as you can go down, right, constant is going only less than equal to thousands. So this will work, it's fine for now. So we can improve this further with a sliding window and frequency map, right? But that's for another video, or if you want this video to be continue, right? So you can ping me in the comment box, and I'll create another video for this problem, right? Or that's all for today, and I'm going to wrap this video today, right? And if you learned anything, something new, hit like and subscribe the button. And if you have any doubts, any problem you are facing, right, you can drop them into the comment box, and I'll create another video for that. And thanks for watching this, and I'll see you in the next one, guys. Thank you. Bye.